This conference will now be recorded.
Okay, so we are back with our casual conversations, and we do have a guest speaker with IMI, Brian Trimble, who we're going to kind of get a perspective of what it's like to take this system and put it into the Masons' hands, and walking through kind of what he sees in the training side of things. So, Brian, I'm going to just start off here and show you. We have two ways of connecting here. One with this shark tooth insert you see which has a welded on lintel, and then we have these brackets.
Right.
Are you seeing one over the other that?
I guess we're seeing a little bit of both. I mean, I'd have to say that the brackets are certainly more popular at this point and so on. And again, I'm not sure why that is, but I think again, it all comes down to adjustability. Is it easy for the mason to install onto something that may not be exactly flat? And that's always the challenge. And I think that whatever gives you that greater bit of tolerance or adjustability, I think that's where it comes to play.
Have you started to see anybody talk about the labor of installing it versus what we saw traditionally done? Is that conversation coming in at the training center?
Yeah, I mean, so again, everybody's concerned about speed and cost as usual, and so on. And I think the speed is there. I think people are understanding this pretty easily and so on. There are some things, after the angle gets installed about flashing and things like that still need to get worked out. But I think the speed of it installing is fine. Again, what people are most concerned about right now is cost. It's like, okay, this is more than we're used to, but again, that's because that's what's required. It's not that they, are choosing something more expensive and so on. It's just that this is a more expensive install at this point, and that'll change over time. But that's where we're at now.
I'm curious, those mason contractors that are going to install this, are they also doing the air barrier install, or is that by a different contractor?
Well, it depends. Yeah. So I mean, some of the bigger contractors and so on can do it themselves. So they'll be doing the air barrier and the angle installation. Some of the smaller guys may sub that air barrier out, or it'll be done by somebody else. So yeah, I can't give you an exact answer because it depends. But I think on the bigger architectural projects, I think they're done by the same company.
Yeah, because I'm often wondering if you're going to see more expense over here, but less. You can do faster labor over here because we've got better detailing with the air barrier and those kinds of things that certain contractors will understand. We're giving back just a better system as a whole. And just like I constantly keep talking about to the design community, this idea of if we're going to start requiring this energy performance criteria that you're designing for, and if we're not doing different things to get there, you can't just keep shoving insulation in the wall and expecting ourselves to get the performance. And we have to start saying, how do we get that air barrier continuous so that we get that thermal performance out of our building? How do we get those shelf angles off of the wall for that thermal bridging? And so it just kind of is. I know cost does keep coming up, but you just ask yourself, why are we doing any of it if we're not going to have them actually perform how we say that we're going to do it? Because designing it and how it ends up performing or don't always line up. At least that's not what I'm seeing.
Yeah, well, and you think about it. So who's designing these? Architects or engineers, and do they have any idea of cost? No, they don't. They rely on other people to tell them different things and so on. So I think there is a disconnect. Whether we'll actually have a connection, I don't know. But again, it's the architects who think they're doing great for the world by making their buildings more energy efficient. And if it costs more to do so, so be it. So, and I think that's part of the mentality right now. Again, they're getting the pushback then from somebody who does value engineering and says, hey, wait a minute, we really don't need this. This is saving us 10% energy. Is this really going to help us out, kind of thing? So I think that's happening.
So, Brian, I have a question for you. So I'm going to pivot the conversation a little bit. So obviously, this TBS system, our team views it as this, I guess you could say, God's gift to masonry. But I would like to see hear your point of view of, your hands-on training in your center. and some of the difficulties that masons have come to you with, and then maybe, some advantages or points that you've delivered to them in regards to making that installation more feasible, or, the lack of workmanship being a benefit, stuff of that nature.
Yes, I mean, I'll go to Jeff DeQuay, who's our IMI representative in Chicago. I mean, he's done some different training setups for stand-up angles and so on, and I think we did one in New York as well. But Jeff, when he talks to his folks out there, again, it's getting the mason to just understand that this is a different way of doing things that's coming down from the designers. That sometimes they don't have a choice. So I think they're okay with that. I guess the areas that we see again are, as Linda said, air barriers, but the other one is flashing. So as you get that angle in place and you start to put your insulation in place, how do you integrate the through wall flashing at that point? And right now with a lot of the brackets, there's points sticking out. That again, if you're dealing traditional peel and stick membranes, that's sort of an issue. And so what we've seen is actually requiring, or not requiring, but suggesting some type of a metal flashing or sheet metal piece that goes over top of that. Then the flexible flashing can go on top of that without being punctured, and so on. And I think Sean, I think that's the one thing that the issues that a lot of masons are having is just trying to get the flashing right. I don't think that the angle itself is that difficult. Again, it all depends on your adjustability and how bad the concrete slab or steel beam or whatever it is out of whack. I think those things are relatively easy to overcome.
And so it would be safe to say that an easy amendment to this would just be simply more training, so the masons understand how to apply these flashings, what flashings work best with these systems, and that'll kind of alleviate some of the pain points that you're seeing on your side.
Right. And again, I don't know if Linda, I don't know if you want to, or Shay, whoever had the image of the bracket and so on, if you want to throw that back up on the screen. But again, is there some type of a camphor or chamfer that can be put on some of these products that would ease that transition? So that comes into play too, and I haven't looked at that enough. Oh, and there is. So yeah, it looks like there is a no, that one doesn't. And that one does. So, and again, like you said, Shay, I think just training and how you deal with bolt heads and things like that, that's always been an issue. The stand-up bracket is no different than a traditional shelf angle that has bolts that are attached to the structure. Again, I think it's just things are pushed out a little bit more, maybe a little more pronounced than in the past. And I think the other thing too is the insulation. I mean, I think masons and other installers of the entire assembly have cheated in the past. Like, oh, so what? There's a little bit of thermal bridging here, no big deal. And so they do different things around there. And now you get the designers who's like, okay, what are you putting in between the flanges of that bracket to reduce thermal bridging? It's like, really? Do we really need to think about that? And the designers are saying, yes, you need to deal with that.
So, sorry, Linda, go ahead.
Go ahead.
So I was gonna make another point in saying, do you think the masons, when they're practicing, the install of this system in your training center, are understanding the benefits of why designers are going with this? Or do you think it's simply like, hey, I'm being told to do this, I better learn it and just put it in on the job just because I'm being told to? Or do you think that, like we were saying, there's a connectivity from both sides, understanding that this is going to essentially be an easier installation and make the building more thermally efficient?
Yeah, I think there's a little of that, but I think it's not enough. Again, so you think about the mentality of a mason, and they want to get it done. And so they sometimes don't want to have to think about everything behind that. They just want to say, okay, how do I do this? How do I get it, so that it doesn't create any kind of callbacks and things like that. So I think we'll probably need to do a little bit more of that. I go back to some of our ground certification that we do. So, course, grouting around reinforcement is very important. It's a structural part of a wall. And so we really try to train our masons the importance of that. It's like, hey, when you don't put grout in there, the wall can fall over, you know. And so we instill that within them. It's like, this is why you're doing it. So I think we could probably do a little bit more on this side. Again, I think energy efficiency is just a newer thing. And again, newer being within the last 10, 15 years or 20 years, but still newer, that they have to address these things. So yeah, I think that could help. And having some good explanatory documents that do it easily, I think is maybe missing, because, you know, I go into some of the ASHRAE reports and Morse and Hirschfield reports that talk about thorough bridging, and they get into all these different factors. And I understand it as an engineer, but you know, I'm afraid that Mason's just like, well, whatever, the hell with that.
I think another, sorry about that. Who's up?
Okay. Oh.
You're up, Robin.
I think there's one of the other challenges, back to what you were saying in terms of who's doing the waterproofing. Is the mason doing the waterproofing or the barrier? That cancels out one of the biggest assets to the offset angle, because Linda was talking about how it can streamline the labor. Well, if the waterproofing contractors responsible for the air and vapor barrier, then they're not really getting that benefit. And you get a much better benefit if you're doing both of them. So we've got a challenge in trying to, how do we carry that over to the mason? Because I think any mason that does the waterproof or does the air and vapor barrier will see they get their cost back just in the amount of detailing and time that they're allowed to take off of doing the barrier application. But so when you have another contractor that's doing that, it's kind of a wash. They don't, you know, that's just another challenge we've got to work through in terms of getting masons to not just look at it like, oh, here's something else for us to do.
Yeah. Well, I think you're right, Robin. I mean, you know, you have to convince a contractor it's worth their while, time, money, whatever, to do this also, in addition to all the other masonry stuff. So, and again, that's been a challenge for us to like convince them of these things. Like, hey, you can make some money off of this, but in their minds, it's a hassle. And I think just, you know, showing them, you know, here's what you can make, here's what you can do, here are some of the problems you'll avoid, because now you're doing it all instead of having it having to deal with somebody else's problems.
I wanted to bring up a point. So I have a masonry install background, laid brick, 4th generation bricklayer, pretty much my whole career before coming here. And I'd veneered up underneath and underpinned some offset shelf angles, but they were maybe more of a traditional style that a structural steel company had installed before we even mobilized on a project. And, you know, they follow the plans, they put it right where it's supposed to be. Bricklayers get there, start, you know, we show up, we start throwing our stories on the wall, trying to figure out where everything's going to be. And there's some challenges of underpinning these properly, keeping our heights proper, you know, hitting window sills, hitting window heads on coursing. Do you feel that they're seeing the benefits of having the ability to put this where it needs to be, not only to meet the planned call out height, but also having a little bit of adjustability to make it work with their stories and their walls? Because I just remember sometimes when, like, you talk about the substrate being out of whack, and they have a 4-inch angle. That's what they have. So it follows the bends and twists in the building, and then you get up to it with your veneer and it's straight, and areas are hanging over more than they should be. In other areas, the angle's almost hanging out of the wall. You know what I mean? To where if you're installing this system as you go, you're going to have the ability to put it where you need to. Does that make sense? Are they seeing that benefit?
I'm not sure. You know, so I would go back and say something like, if you can make it so that the mason installs the angle and not somebody else, then you're going to have, you know, you're going to, you know, make that kind of thing go away, that problem go away. But if you're allowing the steel fabricator or the steel erector to put that stuff in place, then the mason's out of luck, and so on. So again, having shorter angles that are easily lifted by masons. Now, again, the one thing that this whole bracket system does is a normal angle bolted to the wall with 4 inches of insulation is going to be an 8 inch by 8 inch angle, or maybe larger. And so with these standoff brackets, now we go back to the traditional 4 by 4 angle, which is a lot easier to deal with, and so on. So so that kind of thing needs to get put into the cost equation as well. But I think the more you have the mason installing the angle, the less problems you're going to have. What Jason says.
Yeah, I agree. I just remember we'd have like job site discussions. We'd have a couple foremans and a couple masons, and the layout was extensive to trying to make sure we're going to hit an existing relief angle where we need to hit it, but we still got to be able to sell our brickwork by the time we're done, So if we're having to manipulate this just a little bit, we have to be really strategic on a way to do it so it's not noticeable, because it is what it is. The steel erectors have came and gone, and they understand steel, but they don't understand storing masonry. I mean, it's generally just the veneer guys that understand how that stuff's going to have to lay out and keep continuous, even joints the whole way up the job. And
well, you think about this now. Think about all the newer range screen systems that are out there that have different kind of grid systems that are applied to the backing that then pick up a terracotta cladding or a thin stone or whatever it may be. And those have to be pretty darn accurate for this all to work out, because there's no leeway. I mean, with masonry, you have mortar that takes up a lot of this, and range screen systems, you don't. So, how can they have better accuracy than we do? And again, I think in many cases, it may be the cladding contractor who's not installing something because the backup's out of whack, and then holding them to holding the GC to the fire, feet to the fire. It's like, hey, I'm not doing this until this is right. And again, we never seem to have time to do that, or else it would happen a lot.
Yeah, that sounds dead accurate.
So I mean, think about those kind of things. Think outside of our industry and go into range screens, and that also helps you maybe think about how your product is installed.
It's a very good point.
You're muted, Mark.
Yeah, sorry, I was muted. I was going to ask you, Brian, because flashings is definitely, I noticed you brought that up as a pain point, and it certainly is one, even for us. Who on the most ideal jobs are you seeing are the people who are most comfortable drawing those out? Because I'm up in Canada, okay, and I come from a general contracting background. And in the ideal situation, the ideal world, you have a building envelope engineer on every job, or someone reviewing your weep system, your cladding. We had an engineer up here I worked with for high-rise work. He did the Bulletin 19 review for the warranty program, and he was very comfortable in troubleshooting leaks, and he could draw flashing details no problem. But I find the architectural community asks us, how is the flashing going to get installed? Yet our engineers are specialists in designing the structural elements, which is the concealed lintel and the thermal brick system, which we're talking about. So I wanted to ask you what you see in your end of the industry. Who is deciding what the flashing is going to be, what it's going to look like, what's the dimensions, the gauges? What's the ideal situation in your world for flashing? Because I see it as something that goes hand in hand with this shelf angle system, and it's got to be kind of dealt with.
Yeah, I mean, you said perfect world, normal world, and that kind of stuff. So the normal world, again, I think it's the architect who specifies these things. They're specifying gauge, they're specifying the details, they're showing those things and so on. And again, it may be a younger architect who has never gotten out in the field and doesn't understand these things. So I think that's pretty common now for larger buildings and so on, high rises and things like that, or mid-rise. I think it's the wall consultant, and WJE or whoever starts coming into play now, and they're making better details. They've been through this. They're the ones who do a lot of the quality assurance, and so I think some of the wall consultants, although I've seen some that are really bad, but in general they have more knowledge, and they're making some of these decisions. Okay, the architect specified this gauge flashing, but we know that that really doesn't work, so we're going to switch it to this. And then again, they're going to incorporate that. So I think normal, I think it's the architect. I think when you get into more specialized buildings or more high profile buildings, the wall consultant.
Okay, that's what I thought. I was wondering, because it does come to us a lot when in reality we really are specialists in the structural support system, but flashing goes hand in hand with it. And we do manufacture the flashings and so forth, but I feel like the architectural community is very uncomfortable with flashing design as a whole, as a whole. So it's not a specialty, as much as we think it is. So it's just one of those things I notice comes up quite a bit. So
yeah, so I did my homework yesterday before I wanted to meet with you guys today and that kind of stuff. So on your website, you have your brick relief angle sheet, which actually should be shelf angle. There's no such thing as relief angle, in my opinion. But anyhow, you show how the brackets and everything go in, but another page could be the flashing. So, having that additional thing, okay, or even, another page that talks about the air barrier. So I know you were showcasing your product and so on, but I think having something else, maybe it's on there and I didn't see it on your website, but, that kind of stuff that goes a long way. And again, maybe it's actual pictures and not details. I know, when Jeff and Pat Conway, I don't know, Jeff DeQuee, he's our Chicago guy, and Pat Conway's our Wisconsin representative. When those guys give presentations and things like that, they're showing actual pictures of the flashing, the standoff angle, and things like that. And that goes a long way compared to just a hand or, CAD detail.
Mm-hmm.
Okay. Any other comments or questions before we wrap this up?
Yeah, I have a question. So I know you guys have hired Morse and Hirschfield to do a lot of thermal bridging stuff and so on. Have they found, to me, all this stuff is crazy. They have these R2 windows that they're ignoring and yet requiring us to have all these stand-up angles and special wall ties and things like that. Have you learned anything from Morse and Hirschfield that would help our situation out or not?
I don't have any of that feedback readily available, but I can find out what that looks like. And I've started to see in different AIA conversations that we're changing what that glazing requirement is as well, and the window to wall ratios, just because, again, we know if we've got a lot of glaze window area in a project, we don't have that energy performance that we're asking these buildings to have. And so I know a lot of that is shifting and changing, but I don't have any of that stuff in front of us as far as if we've studied it or have anything to report back.
Yeah, someday we will.
Yeah,
someday
because you're right. Again, why do we care so much about here when we're letting it all escape over here?
Yeah, and do you guys get involved into balcony connections and things like that? Do you have any products for that? No. Okay.
No, yeah, I don't think we have any balcony connections. We talk about comparisons with our thermal brick support on. I think a scenario that we've talked about as a team before is German Schuck system, which was a thermal broken balcony support. It was used on the slang name is the Radiator Building in Chicago.
Aqua Tower.
Aqua Tower, that's it. Yeah, that's it. And that was originally designed with a Schuck system on the balconies, but it was value engineered out of it, I think, or something like that.
Of course. So again, the concrete people, the balcony people are having the same kind of issues that we are. Them talking about these issues, and of course now they're bowing to the pressure. It's so much more complicated and expensive to attach balconies than it was in the past, but it's all in the name of energy efficiency.
Mm-hmm.
So anyhow,
the first thing that comes to mind is like a extended slab, a projected concrete slab. It's just a thermal antenna hanging out there in the wind.
Right.
Yeah.
I mean, you know, again, in New York City, you see a lot of those exposed slab edges and things like that. Other parts of the country, not so much. But yeah, we've learned some things not to do things like that.
Oh, that's great. Thank you for joining us today. This has been wonderful. I think it's always great to get the other side of the story and share that. The more we can communicate from the design side of what we're trying to do, why we're doing it, what's happening in the design code we have to do, and how that then impacts over here, and let them know so that we can get better at making the whole system go back to the owner and who's paying for it, to have it function the way they are paying for it to function. And I just think we have to keep talking about it in order to get there with everyone. So
yeah, and I'd like to hear, you know, what Farrell and Halpin and those guys have to say about this whole thing too, because, you know, obviously they're your competitors and things like that, and they're coming up across the same kind of issues that you guys are. So you're not alone, but you know, that they're out there too trying to figure it out.
yeah, perfect. Hey, as long as we're out there talking to the Masons, letting them know what's coming and how they're going to need to adapt, and that they can recognize and know how to bid it so they keep out of trouble, that's what I'm interested in helping them do as well.
Okay.
So.
Yeah, and you know, Jeremy and Shane and those guys, we work closely with those folks, you know, to do different training programs. And again, we're in a weird time right now, but when we get back into things, we'll be doing more things around the country to help our Masons and even the architects bring them into our training centers to show them how these things get put together again. So.
Yeah, very cool. All right. Well, enjoy the rest of your day. Thank you for your time, you guys, and we'll see you next time.
Great. Thanks a lot, guys.
Thanks.